Hello and welcome again to the next in the series of my SPSS walkthrough videos. Again, I'm Kalman Andrassy and I'm going to be showing you now how to standardize your scores in SPSS. So we're picking up where we left off with the walkthrough part 2, in which I showed you some of the basic descriptive statistics. This time I'm going to be showing you something that really doesn't take all that long to be able to get, but once you're able to do it, you're able to essentially go about standardizing all of your scores, turning them into z-scores, in order to be able to make meaningful comparisons between one data group and another data group, regardless of how many questions there are in a given question and question category, regardless of the amount of weight that might be placed on certain scores, and things of that nature, okay? So without further ado, it's actually really quite simple, and hopefully this will be my shortest video. We're going to go ahead and do analyze descriptive statistics, but instead of frequencies as we did in the previous video, we're going to do the descriptives tab instead. And then what you'd be able to do is pick any variable that you like. So let's go ahead and do urban, which is, I believe, percentage of the population that lives in an urban setting. You're going to move that over to the right. So normally, if you were to just run this distribution, it would give you your n value, the number of cases that the scores are based on, your minimum value, which is 6%, so 6% of the population living in an urban area, maximum 100, your mean value, which is apparently 55.78%, so any given country in the world, the average percent of individuals living in the urban parts of that country is 55.78%, and then a standard deviation of about 23. That's all well and good, but let's go ahead and load that up again and click this button that says Save Standardized Values as Variables, and we're going to hit OK. So what you'll see is, whereas here at the top it says descriptives variables equals urban slash statistics equals mean standard dev min max, what this is doing, descriptive variables, you've got a backslash save because it's saving the variables as the individual z-scores that are associated with those values, which are based, of course, on that mean, standard deviation, and other factors. So now, whereas before, if you looked at urban, which is right here, you have a vast array of different values. I can run the descriptive statistics here, or I could do a frequency distribution. That would probably be a little bit better. And you'd be able to see then what each of the values are in your distribution. So you got one place that has 6% urban population all the way up to a place that has 100% urban population. Got our mean, our median, and our mode that we can go ahead and calculate out, or rather get by including the statistics if we so desired. It's all well and good, but what does that mean in the grand scheme of things as far as how many standard deviations away from the mean any particular score is? And if you look here at the very last variable, because it's usually going to be the last variable that's created, you have z-urban. Looks like zurban, but I assure you it's z-urban. So this, like I said, it's the standardized values that were created from running that descriptive statistics and checking that Save Standardized Values box. So it will now present, instead of percentages, how many standard deviations away from the mean any given value is. And again, we can right click and we can sort by descending or ascending values, and we can see what our extremes are. So here we've got one that's 1.919 standard deviations away from the mean. And at the low end, our lowest value is negative 2.16 standard deviations away from the mean. So, if you were to try to see if there are any outliers or anything, know that anything that would be plus or minus 3 or greater is generally considered an outlier because it's beyond the typical distribution. We have the empirical rule, 1 standard deviation being 68% roughly of the overall population, 2 standard deviations being 95%, 3 standard deviations being 99.7%. Well, anything beyond that means that there's definitely less than 3 in 1,000 chance that you would have that particular score in any given distribution. Okay? So that's how you can use z-scores and some of the applications of it.